Okay, good morning children. I hope all of you have completed last class portions and studied well. Now we are moving to the next session of the chapter alternating current, and in this session we are going to discuss about the power. Power in an AC circuit. By any electrical circuit, if you are considering voltage is there, current is there, so definitely there will be power also. Okay, so in the case of a DC circuit, we know if V is the potential difference and I is the current passes, the power consumed by that P is equal to, what is said, power P is equal to VI. It is the product of voltage and current. So what is power? What is power? Power is the rate at which electric energy is consumed. Power, it is the rate at which it is the electric energy is consumed. That is the work done by time. It is the rate of change of work done. It is the power. So here also the work done is, it is the consumption of electrical energy. So per unit of how much energy is consumed, that is the power. And how is it different from the DC? DC, no problem. What is it? If there is a 5 volt potential, 5 volt potential and 2 ampere current, we know then power consumed is equal to 10 watt. 10 watt, right? Per unit second. 10 watt per unit second. But in AC, we know it is instantaneously varying. It is sinusoidally varying. It is varying with the time. So we can find out now. We have to find out what is the instantaneous power at the time t. What is the power? And we have to find out as the average value of current and average value of potential we have found derived same way. We have to find out the expression for the average power also. Okay, because the power is instantaneously varying. So what is the average power consumed for a complete cycle of DC, and what is the expression for the instantaneous power for an AC? Okay, so what is the difference between DC and AC? DC, no problem, it is direct substitution. We can find out, we can calculate what is the power consumed by the DC circuit. But in AC, it is instantaneously varying, sinusoidally varying. So what is the power? Instantaneous power. How much will be the instantaneous power and how much will be the average power over complete cycle? So that we are going to discuss now, and based on that we have to study about the power in the different circuits. That different circuits we already discussed. There is purely resistive circuit is there, capacitive circuit is there, inductive circuit is there, and the last one we have studied, it is the series combination of all these things. So what is the power in these different cases? That also we have to discuss. So write down the next question. Define power in an AC circuit. Define power. Wherever it is, it's not necessary it is AC circuit. Define power. Okay, define power. So how will you define power? It is the rate at which electric energy is consumed. Rate at which electric energy is consumed. Now let us move to the next session. So in an AC circuit, we know the potential will be, what is it? V equal to V0 sin omega. Select V equal to V0 sin omega t. And what will be the current? Current I equal to I0 sin omega t minus 5. Minus 5 or plus 5. Anything you can take. That is, phi stands for the, phi represents the phase difference. Okay. It may be 0 or 90 or any other value. So as the circuit changes, the phi value also changes. So general expression we are writing V equal to V0 sin omega t and current I equal to I0 sin omega t minus phi. Okay. So that is phi equal to 0 in the case of which circuit? In the case of a resistive circuit, phi is equal to 90 degree in case of both the inductive and capacitive circuit. And in capacitive circuit, it will be plus phi. Inductive circuit, it is plus 90 and inductive circuit, it is minus 90. Okay, so general expression we are writing V equal to V0 sin omega t and I equal to I0 sin omega t minus 5. So what will be the instantaneous power? Instantaneous power means it is the power at a particular instant. Okay, so instantaneous power we can write, it is the product of what? Voltage and current. P is equal to VI. So substitute V0 sin omega t, I0 sin omega t minus 5. Okay, so expanding and rearranging. So we can take this V0 and I0 together. Then what comes? Sin omega t. Then what is it? This is sin A minus B. What is sin A minus B? Sin A minus B is sin A cos B minus cos A sin B. Okay. So we can expand that in that form and simplify it. Okay. So we can write what is this? Sin omega t minus 5. Expansion and simplify. So here I have write it together because no space on the board. So what is it? E equal to V0 sin omega t, we already discussed. I equal to I0 sin omega t minus 5. P is equal to Vi, substituting for V and I. So what is it? V0 sin omega t, and I expanded this sin omega t minus 5. What is it? Sin A minus B is equal to sin A minus B is equal to sin A cos B minus cos A sin B. Okay. So sin A omega t cos B minus cos omega t sin B. Okay. Then again rearranging, taking this sin omega t inside. So what comes? Sin omega t into sin omega t, sin square omega t cos 5 minus sin omega t cos omega t sin 5. And this sin square omega t and sin omega t cos omega t. It is writing in the another trigonometric relation. All these things you have studied, and if you don't know, you just study it now. So we will get 2 outside because it comes 2 sin square omega t, that is 1 minus cos 2 omega t is 2, and here sin 2 omega t is 2 sin omega t cos omega t. That is a trigonometric relation. So taking 1 by 2 outside, and 1 minus cos 2 omega t cos 5 minus sin 2 omega t sin 5. Again, what is the next one? Again opening the bracket. So we will get 1 into cos 5, it comes cos 5 minus cos 2 omega t cos 5 minus sin 2 omega t sin 5. Opening this bracket. Okay, and I am keeping this inside the bracket. Inside the bracket. So this comes plus here. Okay, this comes plus. So what is it? Cos A cos B plus sin A sin B. This in the form of cos A cos B plus sin A sin B. So what is cos A cos B plus sin A sin B? It is cos A minus B. So we can write this as V0 I0 by 2 cos 5 minus cos 2 omega t minus 5. Cos 5 minus cos 2 omega t minus 5. So what is this? This is the instantaneous power in an AC circuit. So at any time t, see, look at the equation, there is a, this is the phase difference, phase angle. So we know that, and as t changes, what happened? The power also changes. So we can find out what is the power at 1 second, what is the power at 2 seconds, what is the power at 10 seconds, what is the power at 50 seconds. So anything we can find out using this equation. So this is the instantaneous power in an AC circuit. Instantaneous power. Okay. So from this instantaneous power, we can find out what is the total work done. Okay. During an complete cycle of AC. What is the work done during complete what is a cycle of AC, and that will be its average power. Okay. So from the instantaneous power is a constant for a particular instant of time. So as the time changes, how is it is changing, it is varying like this, isn't it? So at each and every time there is a variation in the power also. So at this particular instant, so instantaneous power we can find out. Okay. So write down next question. Derive an expression for instantaneous power. Instantaneous power in an AC circuit. Instantaneous power in an AC circuit. So you can start from here, and this is the expression. This is the instantaneous power, which is constant at a particular instant of time. Okay. So if you have the instantaneous power, we can find out what will be the work done. What will be the work done at any instant? What will be the work done at any instant? So we will get, we are considering for the time, considering the small time dt. What is it? There will be a small work done due to this instantaneous power. This is the instantaneous power. So here in this AC, we are considering this small interval of time. So at this small interval of time dt, we know what is the power. So what will be the work done? So if we know this work done, we can find out what will be the total work done by this alternating current, this full cycle, that is within the time 0 to t. So using that, we can find out what is the total work done, and once we know the total work done, we can find out the average power, that is equal to total work done divided by total time taken. Average power is equal to total work done divided by total time. So now we are moving for this average power. From the instantaneous power, we can find out the average power. Okay, so instantaneous power we know. So for this particular instant delta dt, it is a constant. So during that time, the work done will be dw. So what will be the total work done for the whole cycle? That is from 0 to t. What is it? We have to integrate this dw. Okay. So how can you do that? Integral 0 to t. What is it? P instantaneous dt. Okay. And P instantaneous we know. So we can substitute it. So it is equal to V0 I0 by 2. V0 I0 by 2. That is a constant. So integral 0 to t. What is remaining? Cos phi minus cos 2 omega t minus phi dt. So the variable we have to integrate. Okay, V0 I0 by 2 is a constant, so that is why I have taken it outside. Then integrate. So what will you get? Writing it here. W is equal to V0 I0 by 2. Okay. Then we can separate this. Cos phi minus cos 2 omega t minus phi dt. As two terms we can write. So integral 0 to t cos phi dt minus integral 0 to t cos 2 omega t minus phi dt. Okay. So two steps are there, two terms are there for integration. And here it is cos phi is a constant. So integral dt comes. Integral dt is t. So what is it? So listen. Integral 0 to t we reach here. So cos phi dt. So cos phi outside. Integral dt is t within the limit 0 to t minus, and this term integral of cos 2 omega t minus phi dt. After integrating, it will come 0. Okay, that is a little bit long integration steps. We are not going for it. We are just substituting the value this is equal to 0. Okay, so that is why this is equal to 0. So directly I am substituting. You don't go for that integration step. Okay, so that you will study in maths. So directly we can substitute it is 0. So substituting the limit, that is upper limit is t and the lower limit is 0. So what we will get? V0 I0 by 2 cos phi into t minus 0 is not there. So this is the work done. This is the work done in complete cycle. So what will be the average power? The average is equal to work done by time. Average is equal to work done by time. Total time. Total time is, what is it? 1 period. Isn't it? There is a time period. It is for the 1 cycle. So what is it? Substitute for that W. W we got V0 I0 by 2 cos phi t whole divided by t. So this t get cancelled. We will get an expression for the average power as V0 I0 cos phi divided by 2. Cos phi divided by 2. Okay. Again, a modification in this equation. This is the equation for the average power. So we are writing it in terms of the RMS value. For writing that in the RMS value, I am writing it as P average is equal to V0 by root 2 I0 by root 2 cos phi. I0 by root 2, V0 by root 2 cos phi. Because we know root 2 into root 2 is 2. Just modifying the equation. And we have studied that V0 by root 2 is the RMS value of voltage and I0 by root 2 is the RMS value of current. So we can write it as VRMS IRMS cos phi. So average power over a full cycle of AC, that is equal to VRMS into IRMS into cos phi. Okay, what is the instantaneous power? Instantaneous power is equal to V0 I0 by 2 cos phi minus cos 2 omega t minus phi. At any instant you can find out what is the power in an AC circuit. And from that instantaneous power, we are deriving the expression for the average power and we are getting the average power. So what is it? In this full cycle, at each and every second, there is an energy consumption. And what is the average of all these things? That is the average power. And what is it? It is equal to VRMS into IRMS into cos phi. Okay, that is the product of RMS value of voltage, RMS value of current and a term that is cos phi. In that cos phi, phi is the phase difference between voltage and current. So as the AC circuits changes, what happens? Phi value also changes. Accordingly, the average power consumed also changes. Okay. So write down next question. Derive an expression for average power. Expression for average power in an AC circuit. Derive an expression for average power in an AC circuit. Okay, so you can start from the instantaneous power and the final expression. P average is equal to VRMS into IRMS into cos phi. So we got the equation. P average is equal to VRMS IRMS into cos phi. Okay. And from this, we have to go for the special cases. That is, I told the case of the AC circuit, that is the capacitive, resistive, inductive and series LCR circuit, what will be the average power. So, first we can go for the case of resistive circuit. Resistive circuit. So, in resistive circuit, we know what is phi. What is phi? Phi is equal to 0. Phase difference between voltage and current is 0 in purely resistive circuit. So what will be the power consumed in that? The average is equal to VRMS into IRMS. Isn't it? VRMS into IRMS. Cos phi, that is cos 0 is equal to 1. So this will be the maximum power consumed. So there will be a maximum power consumption when AC passes through a purely resistive circuit. Okay, the current power consumption will be maximum where in the case of a purely resistive circuit. Then what will be the second one? Second one is the inductive circuit. Purely inductive circuit. And in an inductive circuit, what is phi? Phase difference between voltage and current is pi by 2. So what is cos pi by 2? Cos 90 is equal to 0. So in the equation, we are getting the power consumption is 0. Right. So in inductive circuit, the average power becomes 0. That is, when AC passes through an inductive circuit, that is a purely inductive circuit, the power consumption in that circuit is 0. Then the case of a capacitive circuit. In capacitive circuit, again we know phase difference is pi by 2. So what is cos pi by 2? Again it is 0. So what is P average? Here also P average is 0. So in capacitive circuit also there is no power consumption when AC flows. Then the next one is what? It is a series LCR circuit. Okay. In series LCR circuit, what will be the power? The power will change according to phi. Like what is phi? That phi is equal to tan inverse of XL minus XC divided by R. So according to the value of XL, XC and R, we will get the phi value. So phi value is not equal to what is it? 90 degree. There will be a value for phi. So average power won't be equal to 0. Okay, there will be a power consumption according to the value of phi. It may not be equal to 0. Okay, so there is a power consumption, and through which component? The power consumption through the component R, resistor. No power across this capacitor and inductor. Okay, but in series LCR circuit, as a resultant case, there will be a power consumption and it will be only across the resistor R. And the last case is at resonance condition. LCR circuit at resonance. At resonance, what is it? XL is equal to XC. Right? XL is equal to XC. Only what is remaining there? But resistor is remaining there at resistance. So what will be the circuit? The circuit will be equal to a resistive circuit. Will be a resistive circuit. So what will be the power consumption there? There will be maximum power consumption when LCR circuit, series LCR circuit at a resonance condition. So these are the special cases of AC circuit and its average power. Okay, so in the case of resistive circuit, inductive circuit, capacitive circuit, series LCR circuit and series LCR circuit at resonance. So what is the condition here? The average power will be, maximum power will be there. The circuit is a resistive circuit and there is no power consumption across an inductive circuit and a capacitive circuit. Okay, there it is equal to 0. It is very clear from the equation. Okay, so that is the case of the power. So write down the next question. Derive the average power. Derive the average power in the case of A, resistive circuit, B, inductive circuit, C, capacitive circuit, D, series LCR circuit, and E, series LCR circuit at resonance. Derive the power in the case of resistive circuit, inductive circuit, capacitive circuit, series LCR circuit and series LCR circuit at resonance condition. Next is about the power factor and wattless current. power factor and wattless current. So first we will move to power factor. What is power factor? So we know that from the equation P average is equal to Vrms Irms cos phi. The power, average power varies according to the term cos. Okay, according to the term cos. That is, the average power is not equal to the product of the effective value of this potential and effective value of current. It depends upon one more factor, that is cos phi, where phi is the phase difference, and that term in the equation, it is known as power factor. It is known as the power factor. That is, cos phi is known as power factor. Because according to this value, according to the value of cos phi, the power is varying in the circuit. Okay, so this is the product, that is the Vrms and Irms, product of RMS value of voltage and current. It is not equal to the actual power. So we can take it is the apparent power. It is the apparent power. Apparent power. Because the actual power becomes when this factor is also added with this. Okay, so we are taking this as the apparent power. So from that we can define that cos phi is equal to P average divided by Vrms into Irms. That is from the equation. P average is equal by Vrms into Irms. And what is this? P average, that will be the actual power, isn't it? Actual power in that circuit. So we can write it is the actual power, and this is equal to the apparent power. Actual power and apparent power. So how can we define this cos phi? Cos phi, it is the ratio between the actual power and apparent power, or power factor may be defined as the ratio between the actual power and apparent power in an AC circuit over a complete cycle. All these things we are explaining for the for one complete cycle of AC. Okay, so that is its power factor. So as according to the value of power factor, there will be maximum power, there will be zero power, or this power comes between 0 and maximum. Okay, so that is called the power factor. So what is it? It is the ratio we can define. It is the ratio between the actual power and apparent power in an AC circuit. Okay, next we have to see what is this wattless current. So write down the question. Define power factor. Define power factor. When will be the power factor? Maximum and minimum. When will be the power factor? Maximum and minimum. So when will be, it is maximum when phi is equal to 0 and minimum phi is equal to 90 degree. Then what is this wattless current? So look at the case of phi is equal to 90 degree. Phi is equal to pi by 2. You know cos phi is equal to cos pi by 2. What is it? It is equal to 0. So in which circuit it is happening? It is happening in the case of an inductive circuit and capacitive circuit. Capacitive circuit. That is, in such circuit, power consumed is equal to, that is the average power. Power consumption over complete cycle is equal to 0. So when current passes, that is AC passes through the inductor and capacitor, the work done, that is the power consumed, will be equal to 0. So such current, it is known as wattless current. Such current is known as wattless current. Okay, so that is the power consumption. When the power consumption becomes 0, in which circuit it becomes 0, so such currents are known as the wattless current. So what is it? In the case of an inductive circuit and a capacitive circuit, power consumed is 0. So the current flowing through that, it is known as the wattless. That is, what is the unit of power? So wattless, no power. Okay, wattless current. Okay, so that is called the wattless current. So write down next question. Define or what is wattless current? What is wattless current? Wattless, W-A-T-T, W-A-T-T-L-E-S-S, wattless current. That is no power. Okay, that's a current through inductor and a capacitor.